Welcome to our RightScale webinar today. Our topic is hybrid cloud orchestration, how SuperChoice does it, or maybe you could read that, how SuperChoice does IT.
Thanks for giving me the opportunity to talk to everyone today. So what we're just going to run through is what we've been doing at SuperChoice from the point of view of cloud automation and orchestration. We'll give you a little bit of context about where we are as an organisation, just to provide some context for what we've done. We'll talk a little bit about how we've done that, and then we'll wrap up with the things that we've learned and the benefits that we've got out of doing that. So SuperChoice, just to put it into context, and I know there's probably people from different parts of the world on the line, but we're essentially pensions, or what we would call a superannuation company. In the US, you'd probably call us part of the 401k type of environment. We've been running for about 20 years. We are the market leader in our segment, and what we do is we stand essentially between the employers and the pension providers. We take the data which on each of the employees, and we validate it, process it, we figure out where it needs to go. If you give us the money, we'll send that along too, and we'll make sure that that gets to each of the various pension providers on behalf of each of the employees. So that's sort of the role that we have, and we're the market leader in Australia. For those that aren't familiar with the Australian market, self-managed super funds, which I mentioned at the bottom there, that's like a private pension scheme effectively. Most of our clients, many of these logos may be familiar to people, but may not. But essentially, we work with 6 of the top 7 financial service providers in Australia. So certainly we deal with the largest pension providers, but that also goes down to very small ones as well. In terms of the journey that we've been on, the Australian government quite dramatically changed the way superannuation was provided in Australia starting about 4.5 years ago. And when that happened, SuperChoice realised that this wasn't a question of being needing to tweak what we did. We had to fundamentally rethink what we did. And what we did was we completely rebuilt our platform based on distributed microservices. We completely revised the technology stack that we did for doing that. So we adopted the Atlassian tool stack. We focused on Java, and we also decided to migrate from Oracle database technology to Postgres. And then the third thing we did was we completely changed the way that we built that stack. So we went from a traditional waterfall environment to an agile environment. The last component of that was how we managed our infrastructure. And because what we found was as we changed our environments, as we changed to more of a continuous integration, continuous deployment sort of environment, that the infrastructure and the ability to manage and create environments put a brake on our ability to respond to the market changes and our clients' needs. And so that's what's really led us to start to look at how do we migrate to the cloud. So the first thing that we looked at was we realized that when you look at where infrastructure and security were heading, then it becomes pretty clear that that's a scale industry. Now, and we're not talking necessarily about scale from the point of view of purchasing alone, but it's also scale from the fact that you need to be able to train up people and maintain their expertise on a broad range of technologies. You need to have the scale to be able to deploy it and to also get attractive prices from vendors. And what we found, because we're a 100-person company, we didn't have that scale. And it was silly for us to try and pretend that we did. So we decided the only way that we were going to survive was to tap into the scale of others. Now, there were some other reasons that we saw that we weren't going to be able to cost effectively do infrastructure. The complexity, the increasing complexity, the fact that everything was interconnected, the fact that we're moving away from a security model that's based on a hardened perimeter to more defense in depth, all meant the complexity of managing and creating infrastructure and providing that in a secure way was getting harder. And to give you an example, and this was one of the ones we gave the board, for us to provide intrusion detection and protection, which is a fairly standard security control, in our context, that was something like $80, maybe $150 to $150,000. Or I can provide that through a cloud service provider. At the time, we had a quote $150 a month. So you can sort of get a sense that as a small organisation, it just wasn't feasible for us to continue to providing it ourselves. And so that's why we looked at migrating to the cloud. When we looked at it though, if you look at the research, so we took the decision to migrate 100% to the public cloud. So I know people are very fond of hybrid environments. And in many cases, what people do, seem to be doing at least, is they use pre-production into public and production environments into private cloud. We took the view, and we also did some benchmarking from a cost perspective, that it made sense to migrate everything to the public cloud. And then when we did the research, we realized there's actually very few companies that are doing that. And the research we tapped into was from Forrester. And based on their 2015 results, less than 2% of companies are actually migrating completely to the public cloud. The figure on the right around what percentage of the infrastructure, that continues to climb, but still it's a very small number of people. So what were our requirements? The main thing for us was we needed to move away from where, under a traditional environment, for us to create a new environment, we were looking at more than 10 weeks to get that up and running and deployed. And that was when things were going well. For many organizations, I know 10 weeks doesn't sound like a lot, but for us, it was an extraordinary amount of time. We also needed to look at driving down the cost of maintaining those environments, because we saw a future where increasingly developers would be able to deploy their own environments, create their own environments, and then deploy their code themselves. And so that the role of operations and the role of the DevOps guys was much more less about doing and more about how to coach them. We also, people get concerned about vendor lock-in, and equally that was an issue for us. But from our perspective, when we looked at the research and we looked at where things were heading, our view was the scale and the money was always going to be in the cloud service providers. What we needed to do was to have the ability to switch between those cloud service providers. And so that was really what led us to go down a cloud management platform process, was we wanted to have the ability to switch between cloud service providers. Now, I know people talk about this and they say, yes, yeah, I use different cloud providers. I use AWS and I use Azure and that. What they often mean is they use they've got SAP deployed in AWS and then they've got email deployed in Azure. What we wanted to do is to take an entire environment, say a dev or a test environment, and we wanted the ability to decide to deploy that to AWS or to deploy that to Azure or to deploy that to Google or some other cloud service provider, and for that to be able to be done in an automated manner. And part of the reason for that was because we believed there would be benefits out of being able to switch between cloud service providers. And so when we talk about multi-cloud provider or support, that's what we're sort of referring to, is that ability to deploy it across a number of different providers. And we have done that. For example, earlier this year, we had an environment running in AWS, and we moved that from that into a private vSphere cluster that we have as a temporary capacity. And we completely took that environment down, moved it across, had it back up and running in less than 4 hours. And we wanted to be able to do that in with a distributed microservices architecture, which at the time was about 150 microservices, is now just over 200, and that continues to grow. And we wanted to be able to do it in a context where the number of environments was changing dynamically based around the needs of development and the need to support our clients. And at the same time, what we wanted to do to improve our responsiveness was we'd moved from bi-monthly deployments to monthly to weekly, and we wanted to move to daily. And you can't do all that stuff unless you've got it automated. And so that was the broad requirements that we had. So in terms of our strategy really can be distilled down to 2 simple points. But you know, I'll expand that a little bit. But the 2 points really was around the ability to automate everything and the ability to be cloud service provider independent. That's what drove all of our decisions. Now, part of that, obviously it's easy to say that, it's a little bit more complicated when you do it. But part of that was around the way you do the automation. So what we wanted to do was to not deploy components. We wanted to deploy completely functioning full environments. And we wanted to be able to do that in a repeated way. And we wanted to do it quickly. So we can now we've got to the point now where we can deploy an entire functioning environment without anything being in place, but have that entire environment, including the infrastructure, the application, the database, everything, all up and running in just under an hour. And that gives us huge benefits, you know, particularly from the point of view of when, from a production support perspective, we can create environments on the fly to look at specific issues. From a client perspective, we can create dedicated test environments that they can use, which we didn't have the ability to do before. The second component there is what we've called fix by rebuild. This is quite a significant mind change. And the reason why I say that is most of the people in operations, their sort of focus is very tactile, and it's based around, I have a problem on the server, I'll go and fix that server, I'll patch it, or I'll patch a specific issue. When you change infrastructure to being effectively a code, and that's what it is now, infrastructure is just code, then I can start to apply all the software quality techniques that developers have been doing for years. I can start to apply that to infrastructure. And when I do that, it changes the nature of how I maintain that infrastructure. And it's much more of a systems thinking sort of approach. So you actually stop patching or dealing with individual servers. What you do is you go back to the source code, you update the source code for the infrastructure, and then you rebuild it. And that's what we mean by the phrase fix by rebuild. So you stop patching things, you actually go back to the source, change it, and then completely redeploy that environment. And because you can do that in an hour, it's feasible. But that changes so many things in so many subtle ways. Like, you know, people often ask, about, and I mentioned before about security, that ability changes the way you think about security quite fundamentally, because now I have a model. So we've got over 234 Tomcat instances, something like that. It's probably more than that now. When we need to patch that, we don't have to go patch each of those instances anymore. We go back to the source code, we update the source code, and then we redeploy the environment, and poof, they're all now updated. So you can, the ability to maintain and keep everything up to scratch from a patching perspective has changed quite dramatically. And that's just one example of the fundamental change in the nature of fix by rebuild provides. And then the last point there, which is around supporting multiple cloud providers, that's really, there's so many different, like the cloud providers lock you in. Yes, you can get them to do backups for you, for example, but those backups aren't interchangeable. And so what we had to do was to really think carefully about how we were doing the automation and the building, so as to be clear about where we were making use of a capability that locked us into a cloud service provider versus where we weren't, and how we were going to be able to maintain that flexibility to deploy across cloud service providers. And to give
Ian,
you a bit
if
of
I can,
yeah, sure.
If I can jump in and just add a bit there, I think it's important for the audience to realise that this is talking about not just all the new microservices applications that have been written over the last few years, but also some of the legacy applications that might have been around for 15 plus years. And the second thing to mention is that really what we're talking about here is what I see as a logical extension of the CI/CD processes to include the entire infrastructure stack. So we're increasing the size of the deployed unit, including the entire infrastructure stack right the way through to the application. And speed and cost of being able to manufacture an environment of that level of complexity is the key to the fix by rebuild approach.
Yeah, that's a good point. I mean, it's interesting to note, many people start by doing this and deploying their new stuff. So in our case, it would have been the distributed microservices. As Brad knows, the very first application that we migrated to the cloud was our legacy application. Now, we did that in response to a client need, but this wasn't just limited to sort of the new stuff. The approach actually allowed us to deploy our legacy applications as well. So the benefits that we were hoping to get out of that, and I've touched on some of these already, but was really the ability to deploy in an automated fashion to actually, it was actually a little bit more than that. It was the ability to put into the hands of the developers and the testers the ability to create whole, complete environments. You know, I'm sure we're not that different, but we'd have problems with developers who would be trying to test code in the same environments that the testers were testing, in the same environments that the performance testers would be doing load testing. And that created problems because they were all doing that on top of each other. Now, when we built this, we then shifted to a model where a project team, the developers could create a dev environment just when they needed it. The testers could have a separate environment that they created when they needed it, but was distinct from what development was doing and was distinct from what the performance guys were doing. This is dramatic. The ability to do that on demand has dramatically improved the quality of the outcomes and the productivity of the developers. You know, the old days, people used to worry about optimizing resources. Now it's about optimizing the resource being the developers and testers, because that's where the cost is, and they're the guys that have the biggest impact on the outcomes. So what we wanted to do was to empower them, and we did that by wanting to do that by deploying entire environments. As we said, we've got it down now to about 60 minutes. The developers, we've now worked with the developers so that they can do it themselves. So our DevOps guys have moved away from doing deployments themselves to supporting developers doing that. We wanted the ability to track the costs of those environments, because obviously one of the things people can get concerned about is proliferation of environments sort of blowing out the costs. We wanted to be able, have the ability to pick and choose between different costs and understand what it was that was driving that. So, for example, we've done some work around the use of standby pricing, reserved instances, those sorts of things. So we wanted the ability to understand that, and we wanted the ability to be able to pick the environment that made the most sense given the load characteristics and the requirements. So, people, this slide's a really interesting slide, because people, when they talk to us, they sort of say, yes, we understand, we've migrated to the cloud too. The reality is that's often not the case. And we try and use this slide to explain this, but essentially there's 3 ways that you can migrate to the cloud. You can think of the cloud as just being a replacement of your own physical infrastructure. I run a data center, they run it for me. That's the straight physical replacement option. That's what a lot of people do. Or when you start to talk to them about automation, they then start to talk about, yeah, we automate that process too. What they're really meaning is they probably use something like Puppet or Chef, and they automate the infrastructure deployment process. But they still have to do the traditional deployment of the application code on top of that. They still have to do a lot of the configuration around it. What we wanted to do, and where we think you get the real value, is what we've called automated environment provisioning. And that's where you can deploy complete environments. So the infrastructure stack, the application stack, databases, and all the stuff that needs to sit around that in terms of security, comms, network, and to do that in a fully automated way. That's what we mean when we talk about our automated provisioning.
If I can add to that, Ian, I think, it's important to note that probably, I think, a good 60 to 70% of the world are focused on really what is a migration of a lift and shift into the cloud to date. And certainly at those first couple of steps in the journey, you're going to get a lot of cost efficiencies, and that's all good. But it falls well short of what is possible with automation and orchestration techniques when you push the boundaries like what we're doing. But I think for the audience's perspective, most of what we're going to be talking about in the case study, which is SuperChoice, is the fully automated provisioning at the end of this chart. So we're talking about, it really is possible for a business now to provision highly complex, functionally complete environments from the network up that involve suites of applications and databases, do that at scale, and do that into any cloud, be that public or private, within an hour, consistently and repeatedly, and as often and as many times as they like, with different deployment purposes being dev, test, and UAT. And that capability that we're going to be talking about further through this journey is really only possible with that automation. The automation is the key.
Yeah, I think to illustrate that, as you know, Brad, we're now maintaining about 5 times the number of environments using this process with effectively the same number of people. So the ability to support and the productivity improvement you get is quite substantial, and that's just, on that aspect of it.
Yeah, agreed.
So when we talk about fix by rebuild, this slide sort of tries to explain that. It's really that systems thinking approach. And what I mean by that is, with systems thinking, if you don't like the outcome, you don't change the outcome, you change the process that produced it. And that's a little bit like what we've adopted with fix by rebuild. So we have, everything becomes now software. So when we talk about automated builds, we're actually talking about we've automated not only the code deployment, but all the database changes. And remember, just as part of the context, in the middle of this, we've been migrating off Oracle to Postgres, so that in itself was not a trivial exercise. And the other thing we've done is we also source control the config. So in the old days, people would deploy code and then they'd make database changes and then they'd update the configs. Now that's a completely software-based and automated process. And we use RightScale to manage all that. So it does all the configuration, it does all the automation and the deployment. The way we typically go about it is, as I mentioned, we've adopted the Atlassian stack. So we use Bitbucket for all the source code, Bamboo and Maven to build it. We deploy all the deployment artifacts are stored in Nexus, and then RightScale drags from Nexus to do the automated deployments. But the process we use is, go.
Yeah, if I can jump in, I think it's important with this slide to really start from the right, and the outcome that we desire is a disposable environment. What I mean by that is an environment that has very limited and or no asset value. So we want to be able to deploy an environment for a specific purpose and then literally discard it when it's achieved its purpose. We can achieve that by looking at that middle section, manufacturing process. If we can build an environment, no matter what the complexity, in an hour or so, then it is possible to do this at scale and do it frequently. And then over on the left, the control, where it says the control master, the software management disciplines of having everything versioned and having everything as collateral that is necessary to build that environment is the key really to achieving this. So irrespective of the different people in the organisation, the different subject matter experts that might be defining specific configurations for a unit of collateral that needs to be deployed, they are accountable for it, they're accountable for the outcome, but they're not actually involved in the execution once we've captured all of that source code associated with it. So when there is change for whatever reason, that change is applied at source, and then we remanufacture an environment.
Yeah. And the other advantage of that is it means stuff isn't just kept in people's heads, because it's, that IP, if you like, becomes part of the scripts that are run, the files that determine that automation process. And so there's a whole bunch of benefits that you get out of this. But it's a different mindset when you start to think, I'm focusing on the environments, which is the use box there. When you need to move away from thinking about individual environments to the process for creating those environments. And that also opens up other possibilities, like historically, when we did infrastructure deployments, we sort of tested it by making sure the application run on it. Whereas now because it's all software based, we actually run regression tests through it to specifically look at the infrastructure deployment components to make sure that they've worked correctly. And we do that in a repeatable way. And so it does change the way you think of things. It's more about, let me try this, deploy it. If there's an issue, I throw it away. I go back, I fix the source code. So it's much more like a software deployment. And therein lies where some of the challenges have been, which is around getting people to think differently about that.
Yeah, well, let's face it, with the costs associated with infrastructure, 5 or 10 years ago, you couldn't do what we're talking about. But with the costs of consumption infrastructure from the cloud, you can actually do that iterative step as many times as you like, relatively cost effectively.
Yeah, exactly. So maybe, Brad, this is a good opportunity for you to take us through some of the details of that.
Yeah, so this slide provides a little bit more of the detail. I won't go into the detail to any great extent, but it exposes the fact that for us, RightScale is that manufacturing platform. RightScale is the version management repository for some of that collateral, not all of it. Some of it will be in GitHub or Nexus or other repositories, but a lot of the key information is in RightScale and version managed. RightScale is also the API and the engine that we use to access the multi-cloud and be able to pick and choose the various clouds that we want to use. And RightScale, importantly, handles all of that workflow and complex orchestration for us. So do you want to go to the next slide, Ian, for me? So on the next slide, we're really talking about, the key message is that we're taking a standardized approach to solution architecture with what we're doing. So we're attempting to eliminate all the configuration variants that you might get, combined with simplification of deployment models and various separation techniques and standardization techniques. And this allows us to construct a very cellular-based or building block, or some people might refer to it as a cookie-cutter approach, to be able to deploy services and complex environments at scale. The key concepts is that we are really talking about software 101 here, where we're talking about separating information from execution. We can then, so the model of information associated with an enterprise environments includes applications, networks, firewall rules, databases, all the contextual information and configuration, and we can structure that into the various cells and logical groupings. And when you do this right, the configuration information should become immutable, just like your code does. So you can test and treat your configuration like you do any other code and push it through to production for full stack deployment. So we're pushing the boundaries, we believe, of infrastructure agility to the same extent probably that people pushed software agility in the early 2000s. I think if you want to move on to, you've just advanced one slide too many actually, Ian. So our solution involves having an information model, the solution that we've helped work on with SuperChoice and create for SuperChoice. It involves a quite extensive information model or meta model, but also the ability to automate the build of the execution program. So for those who aren't familiar, or maybe as familiar with RightScale as Ian and myself, there's a couple of key constructs that RightScale delivers, brings to the party. The cloud application is actually a workflow engine that executes a program, and that program is called a cloud application template, or a CAT, and the CAT is executable. So the CMP executes on that CAT, but what we do is, rather than attempt to manage dozens and dozens of CATs that we might have, so when you think about the different deployment models or different deployment sets for multiple applications, ABC, etc., different data sets that you might have in your database for production versus test data, having different deployments of test or dev or UAT. The reality is you can get to the stage where you might want to manage many dozens of cloud application templates to handle all the different requirements and deployment scenarios. So what we've done is actually abstracted out all of that information into a metadata model or an information model, and then we will automate the build of the actual cloud application template. So we also automate the build of that execution program, drop it into the RightScale platform, and then RightScale is the manufacturing engine that goes and delivers that environment into the cloud. So that, in a nutshell, is probably a key aspect of what we're doing for SuperChoice. If you advance the slide. So on to the lessons learned. I think the first point to make is that CI/CD toolings and process are critical. What we're really talking about here is test-driven development, and as mentioned earlier, you couldn't really do that in the infrastructure domain cost effectively. 5+ years ago, we can now do it cost effectively. Cloud makes it possible to actually take a test-driven development approach. To achieving that with full stack automation, you need to build from the ground up. So without the CI/CD and the ability to deploy frequently, you would compromise on having that continuous feedback cycle that you need to have in order to move through to that fix by rebuild model that we've been talking about. Do you want to add to that, Ian?
Look, I think one of the values that we've got out of this is the fact you've got a fully automated, continuously rebuilt process. It drives obviously the productivity, but it also drives the quality. And that's, people probably often focus on the cost side of things, but I'd probably say the reason why our board went down this path, the organisation went down this path, it was more driven by the ability to expand and do more things, but it was around improving the quality of the outcomes. And I think, that's what was critical about the continuous integration, continuous deployment sort of processes, and the ability of the automation to support that. And I think, that leads on to the next point, which is probably, there's been two big areas, I think, of change that have occurred. But one main, and probably maybe the most difficult one, has been getting people to actually think completely differently about how they do their day-to-day jobs. And that includes not only, the obvious ones like the operations staff and the DevOps guys, but also the developers. Not all of the developers actually want to move to a model where they have this ability to create and deploy complete environments. Some people actually just like building code and tossing it over to the testers. But, handling the change management of the people has been a big issue for us and a big challenge. And it also created new roles. Like, we've had to create roles where people focus on cloud processing and environments management and things that sort of seem obvious, and you can sort of say, well, why didn't you do that before? But the nature of them and the way that you have to do them has changed quite substantially now, because we've moved away from this model of where the operations guys did this stuff to now it's all automated, so they don't actually have to do it. What they have to do is help coach the developers who now have that power in their hands to do it themselves. And even the process that we talked about earlier, which is fix by rebuild, that's a different way of thinking about things. And we often, one of the things I used to get a lot from the operations guys was I was trying to turn them into software developers. And yeah, you're right, that's effectively where things were heading. Obviously, cost to value needs to be tracked. This actually gave us, it's interesting, the ability to deploy in this sort of fashion test environments gave us the ability to provide dedicated test environments to our clients. So if you imagine our context, we're a software as a service provider effectively. All of our clients would be testing any changes we're making in the one client acceptance test environment. This capability gave us the ability to go to the largest financial service institutions in Australia, and so rather than you have to do that with everyone when we need you to do it, we'll now give you a dedicated test environment, and you can do it whenever you want to do it, and we'll just turn the environment on when you want to use it, and we'll turn it off when you don't want to use it, and we'll just charge you for what you use. That was huge. In the first 12 months that we had that capability, and we didn't really even market this, that ended up constituting 5% of our revenue for the year. That's a huge impact. And that's a huge impact, not only from a revenue perspective for us, but for all our clients who were suddenly able to decouple our deployment requirements to satisfy everyone to what their particular needs were. And I think that was a huge change for our clients that they've appreciated. And then the fourth point there that I'd mention is this, the concept of brittleness. Whether you realize this or not, when you deploy stuff, there's 1,001 problems that are usually going on that your ops guys massage, cajole, change, address in order to get the code into the environment and deployed. We actually found some code that had never built properly. It had been that way for 2 years. And what was happening was the ops guys, when they deployed it, they knew how to sort of push it, change it to get it in and get it working. But when you automate the process, it becomes what we've called brittle, in that there's none of that. It either works or it doesn't work. Now that's a great thing, because if there's a problem, you know about it straight away. Those problems don't get hidden in the sort of by well-intentioned operations people compensating for them. They actually get called out, you fix it, and then you redeploy it. And what we've found, and it's been really, from our point of view, this has been one of the major benefits. Our deployment processes, there were always problems with them, and those problems have virtually disappeared. And it's driven by the ability to automate, but it's a consequence of this concept of brittleness. So that's been a real learning point for us. And maybe
it's a good point to make, that you should embrace that brittleness, because every time that the process of deployment doesn't work and you identify what that cause is, you fix it back at source, and eventually you've captured all of that corporate knowledge and made the process more robust at every step that happens. So it should be embraced.
Yeah, absolutely. And a manifestation of that is configuration drift. That whole issue where people would make changes on specific environments, forget to update at the source, and then you do the next deployment and you'd have a problem again. We estimated that of our deployment errors, 60 to 70% were due to configuration drift. That virtually was eliminated overnight by being able to automate that whole environment deployment process. That's been a huge improvement on the quality of our deployments, virtually overnight. So, I wouldn't underestimate the value that people can get out of that. In terms of what have we achieved so far, one of the other things that people really need to understand is, as you go down this path, all of the problems that you've got hidden in your infrastructure and your deployment processes start to get brought to the surface. So I would estimate probably 40% of the effort that we've had to put into this has been focused around fixing what I'd call historical tech debt. Now, that's improved the robustness and the quality of our processes enormously, but if you go down this path, you just need to be aware up front that's going to happen. We can automatically deploy 100% of our code. We've decommissioned environments. We've moved everything to software, so our firewalls are software backed now. We've developed a backup process that doesn't lock us into a particular cloud service provider. We've spun up dedicated test environments. We've upgraded our build process. We've improved our security, and we continue to do that. And we've made transitions some of the staff. So we've actually achieved quite a lot. What's been difficult or more difficult? Yeah.
If I can add to that, Ian, I think just going back to that tech debt, I think that's a really important point. So there's many aspects to tech debt that the methodology allows us to handle in one way, shape or form. So, we could also handle the legacy and give it a new lease of life. That's a way of handling tech debt. We're also capturing all of the corporate knowledge in source code as readable code, human readable code. So the corporate knowledge is captured, and we can then evolve that code with confidence because there is that ability to go back because it's under version management. So I think those are all important points to mention.
Yep, absolutely. The other thing that you need to think about was the order that you migrate the applications in. That does take a bit of thinking. We were originally going to start with our new code, our distributed microservices architecture. We ended up going with our legacy apps first, and that created some challenges. The other interesting thing that we found was people weren't always particularly clear about what they meant by a dev environment or a test environment or a user acceptance test environment. And so it was interesting to go through that exercise of having to try and get some clarity around what we meant by that. The other thing is, people talk about doing stuff in the cloud and that creating the ability to migrate things quite easily. You have to be fairly careful. Most people, when they say cloud, they actually think AWS. And it's interesting, you can very easily, if you're not careful, get locked into an ecosystem. And that's been one of the challenges for us, is to just be very clear and very deliberate about that. Comms does also become an issue as you start to look at moving things across applications across clouds, and then how you shift between them can become an issue. And then some of just little things that come up that we didn't really even think about, like error reporting. Most developers think of error reporting as like we're going to write logs to a file, or we're going to print out some error messages. But when you move to the cloud, how do you know that stuff's always going to be there? Or, the ops guys aren't used to thinking of, like, now infrastructure as code. They're not used to thinking about managing code branches. And they're also not used to, when something fails, just relaunching the environment rather than trying to fix it, or at least going back to the source code, changing it and then relaunching it. So there have been some of the issues that we thought were a little bit more difficult than when we went into this. What's surprised us, obviously, the amount of tech debt that we had to address. But again, our approach to that was more, this is an opportunity to make our systems more robust, improve the quality. Interestingly, not the fact that I've said that, benefits have been higher and the costs have been pretty consistent. So the automation process was actually much more efficient than what we thought going in. And so that sort of balanced up the fact that we've had to spend so much more time addressing tech debt as we went through. Interesting thing about cloud service providers is they're all interested in doing work with you until you tell them that you want a multi-cloud capability. And then they start to lose interest. And that manifests itself across a number of dimensions, but it is something to be aware of. A lot of vendors and people will want to help you, but they want to lock you into AWS or to Azure, or in Australia with Google opening up with Google. And you just need to be careful about that. Obviously, the demand for dedicated test environments surprised us a little bit. And the other thing was, we found that we had to be careful about how we manage the pace of change for the ops teams and the rest of the organisation so that they could handle it. We had to break it down into sort of sub-goals that they could then focus on and then build on that to move to the next step. The biggest challenges have been the people. And that's about the new skills that they had to create, because this is much more about conceptualization skills and analytical skills. It's getting the ops guys to start thinking like developers. It's getting the DevOps guys to stop doing stuff and acting like coaches. And it's also, and this goes back to the issue around conceptualization skills, it's also about, when you go down at this systems thinking type of approach, you need to understand how the whole thing fits together and work. And helping people to understand how it should all work was a non-trivial exercise. And so when you step back through the challenges we've had and the issues that were different than what we thought going in, they pretty well all go back to people issues in some way, shape or form. Our observations, obviously, when you think about it, automation is absolutely critical. We could not maintain 5 times the number of environments that we do today if we weren't automating this. It really improves and increases the importance of the people that you use, their skills and their mindset. It's a different way of thinking about it, whether it's the fix by rebuild, whether it's the whole automation approach. But it is a different way of thinking about it. And so it is part of a cultural change. It's even just deploying so that all the developers now have the ability to deploy their own environments becomes a huge cultural change issue. Obviously, when you go into this, I know people who have done, shift and drop deployments to the cloud. They then spend all their time fixing up the tech debt in the background. It ends up costing you more. If you get the chance, fix it up on the way through. It's not a straight lift and shift. It is about uplifting capability, and it is about fixing things and making them stronger and better as you go through. Best way to do that is taking a very deliberate, methodical approach. And then
I think it's fair to say that once you start on the sort of journey we're on, and you start with automation, the more automation you do, the more you want to do, because you start to realise greater and greater agility, flexibility benefits from it.
Yeah. This last slide is somewhat tongue-in-cheek for those that haven't picked up the Australian sense of humour. So that brings us to a close of the presentation, but I hope that's been of some interest for everyone. And I'd certainly, Kim, if there's an opportunity to take some questions, welcome you the opportunity to do that.